This is Dr. R. Obulakonda Reddy, Department of Cyber Security. Now we discuss the concept of high performance computing. First, coming to the introduction about high performance computing. So, devoted here that high performance computing is devoted to creating a powerful tool. A powerful tool creating. Sorry, it's a field of computing. See. Field of computing, the definition coming to the definition there. Field of computing, dedicated development of powerful system capable of handling complex computational tasks with the help of a advanced software and specialized hardware and with use of a tools. So this is a definition of high performance computing. In other ways, we can say that definition is dedicated. So dedicated to creating a powerful tools, powerful systems for complex tasks, surpassing conventional computation with parallel processing, specialized hardware, advanced software, and the use of a different tools. So that is high performance in definition. Another definition. Now coming to this introduction part, this is a computational task, solving computational task with a parallel processing. So illustrating the concept of handling computational task in high performance computing. First one we discuss with a parallel processing. What do you mean by the parallel processing? So now see here multiple cores. Cores means here multiple CPU cores or GPU. CPU means that central processing unit. That has to be taken one by one, instruction has to be executed here. GPU means graphics processing unit. This is another core. So core system that has to be handled with that has to be handled the multiple instructions. At the same time, GPU will handle with the machine learning methods also. Graphics as well as the machine learning methods has to be dealt with a GPU processing units. CPU, that or is that central processing unit that have memory, processor, and arithmetic inside of that CPU you have it, arithmetic and logical units also. Now coming to this parallel processing, the main high performance computing will see that parallel processing. Parallel in the sense multiple CPU cores. Core in the sense the instructions executed simultaneously. Instructions are executed simultaneously. So now see here multiple CPU cores are GPU units processing tasks simultaneously. So for this achieve for a parallel process. Now the example of this one is visual representation of CPU or GPU with multiple cores. Cores means it's executing the instructions. So that is called as a core. Executing different threads concurrently. So the parallel processing, it has to be executed simultaneously instructions, either CPU or GPU, multiple instructions simultaneously. So that is coming to a parallel processing. And the second thing is data visualization. So in real time, depicting the real world complex data sets. Now depicting the real world complex data sets. For example, if you take a 3D graph for displaying a scientific data or research data, and the heat map, that is for simulation purpose, that's used for a heat map. This is another thing, representation of visualization. Then representing which has to be a simulation research. So these two will see in first in this one parallel processing, data visualization. Whatever the real world data complex data sets, we have to take that one, that has to be visualized in either 3D graph or maybe a heat map. So heat map for simulation purpose and 3D graph for this is for scientific or research data has to be visualized. Parallel processing means that simultaneously we have to execute it with multiple instructions. That is a concept. And next see here third one, supercomputer. So supercomputer which has the facilitated with a row. Here see that facilitated with the rows of server racks and high-speed networking infrastructures. So it is a high speed computing. Supercomputer, in other words, we tell that it is a high speed computing. So now it has a facility with their rows of server racks and high speed networking infrastructures, which has to be a container, high speed networking infrastructures. So it can solve the multiple. So supercomputer, that performance gives a very high. We'll see later that. Now scientific. Now other thing. Fourth thing is a scientific simulation. So what do you mean by the simulation here? The results. For example, if you take as a scientist or engineers running on simulation on a high performance computing systems. So for example, if you see digital rendering of fluid, for example, fluid dynamic structures, digital rendering of digital rendering of researcher analyzing fluid dynamic structural emissions using HPC softwares like whatever the fluid dynamic analysis that will be rendered to a digital analysis. We have to analyze through a digital, we can fluid dynamic analysis. So that is simulation results. Whatever we have to give a blueprint that has to be performed with a simulation. Now other thing is a cloud computing. So cloud computing, the infrastructure, whatever the cloud-based resources that has to be using a other term. So high performance in computing that has to be dealt with a HPC. What is this? Another term we have to write as a HPC. What is that? High performance computing. So in this high performance computing, cloud-based resources of a HPC, high performance computing, that has to be used for a task. So whatever the implementation of it, whatever the HPC of a system that has to be implemented by a cloud system, that will be held for a task. So now illustrating cloud-based HPC resource being utilized for a computational task. So that comes under with a cloud computing. Now see the other thing, AI and machine learning. So other thing is a AI and machine learning. So now training a deep learning models. So we want to train our deep learning, machine learning, or deep learning model. This comes under AI, artificial intelligence, and the neural networks and HPC. So infrastructures. So this is the AI. We want to train with the AI and machine learning tools. Then HPC, use of HPC, we can implement this AI and machine learning tools also. And other thing is a real world applications. In real world, we have used with a healthcare, finance, and weather forecasting. So these three, mainly we have to focus on these three things for real world application, use of a high performance computing systems. Now other thing is network interconnection. So now we see here highlighting the high speed networking interconnect used in HPC cluster for communication between nodes. So this is the thing. Highlighting the high speed networking interconnect. We have to interconnect it with high speed systems. Then we have to perform that performance. We measure with that performance. Now other definitions also we can see here. What is that high performance computing? So here see that originally implemented by in supercomputer for scientific researchers. So high speed computing. Now we tell of that nowadays we tell of high speed computing. So high speed computing in the sense is originally implemented for a supercomputer for scientific researchers. Now coming to tools and systems. So this is two things here then. Tools. Use of some with help of tools and systems able to implement and high performance computing systems with help of first all achieving the high performance computing. Then we use with help of tools also. So now this one used for scientific research or computational science. So main area is parallel processing. So here coming to the picture is, so developing a parallel processing algorithm. This is the main thing. Now we focus on parallel processing algorithms. So parallel processing algorithm in the sense simultaneously at the same time we can perform with a different instructions executed. So that comes under parallel processing. So now see here parallel processing and whatever software we have to implement it, so that the program can be divided into whatever the largest program that can be divided into a small piece of a code that will be simultaneously run, and finally it has to be a combined. Now so small into a small independent parts can be executed simultaneously by separate process. So parallel processing in the sense we have a different systems in nodes. That systems is called as a nodes. We have to a rack of a nodes. The task, whatever the largest task, that has to be that has to be divided into a number of parts that will be executed with a different nodes. So that is comes under parallel processing. Now see here HPC system, this is the main important thing. Now here what is that? Shifted from supercomputer to computing clusters. So up to that one range, supercomputer will give a performance. But extension of that, now we have to convert it with supercomputer to computing clusters. This is the very important thing. Now high performance computing, whatever we discuss with a supercomputer in the sense that has to perform with a that has to perform high speed computing, accept it. Now that will be help for a scientific research. But now we want to high performance computing, it has to be converted with a clusters. Cluster in the sense, see what is the clusters here. This supercomputer, whatever it is there, that has to be converted into a clusters. So what is the cluster? So now I'm telling that. So here observe that this is a group of systems, a number of systems. This is called as a clusters. What is the definition of a clusters? Group of missions interconnected in a way that they work together as a single systems. So now these are all the nodes. Each one is called as a one node. This is a group of nodes is there. Node in the sense what individual mission, individual one system is called as a node. The terminology used in a cluster. So interconnected, a group of missions interconnected in a way that they work together as a single system, whatever is there now. So for example, users, first users is there, the user has to be connected with a master node or head node. That after that it has to be connected with a network switch to a cluster in the sense a group of a interconnected systems. Each one we tell as a, it is called as a node. So what is a node? Individual mission in a cluster is called as a node. What is the head or master? Which is connected to both private and public networks. At the same time, it's providing user environment to work and distributing tasks among other nodes. So this is the activity done with a head or master nodes. This is done, the processing is done here. So what is that head and master nodes? This is connecting with a both the private network as well as the public network also. At the same time, it has to be a providing user environment to work, at the same time distributing tasks among the other nodes also. And last one is the computing node. This is especially for a private network. So whatever we done that, it is connected to only a private network. And whatever we have assigned jobs, that has to be a complete. So this is clusters. Now see here, what is the benefit of clusters? Now see here, what is the types of clusters? Now previously we see what is a cluster, and then regarding the cluster discuss now. Then here type of a clusters. What is the type of clusters? Here now storages. So in a clusters we have to use a storage. In storage, see here consistent file image that has to be shared with a either consistency, provide a consistent file system image. That image has to be in a whatever we have stored in a cluster, whatever the file. This is assume that this is called as a file. Assume that it is a consistent file system image. Then allowing simultaneously read or write. So this has to be either read operation or to be a write operation. Read in the sense like this. Whatever the content is there, that has to be read from here now. Or writing the file content, image content, whatever it is there, that has to be shared, single shaded file system. Allowing simultaneously, it has to be either read or write to a shared file system. Whatever the file system you have to store into a cluster system, thus simultaneously it has to give a simultaneously permission to either read or write it. And then high availability, always it should be availability. So now availability in the sense always it should be availability. Anytime you have to give in a task, that has to be completed and given it. Whatever you given a task, that has to be completed. Now providing continuous availability of services by eliminating the single point of a failure. So this is the important high availability. Always it should be available the cluster nodes. But that is the second thing. Types of a cluster, high availability. Simply we call HA. Then other thing is a load balance. So sometimes we have to give in more tasks to a cluster systems. That has to be a balancing. Balancing in the sense the cluster equally divided, equal or maybe a divided fast processing systems that has to be equally divided with a different system. Like we have given as a assigned with a 5 systems. Then we have given a 10 tasks to given to a here. So what happens to that? Each node will divided with a two tasks, and then it has to be taking two tasks. It has to be executed. If it has to be a failure any, for example, if it is failure for a fourth node, then what happens? This work has to be distributed with the remaining nodes. So that is load balancing. In case if it is failure of a fourth system, then what happens to that? Then that load has to be distributed with the remaining, that will be shared with the remaining cluster nodes. So that is load balance. The node has to be a balancing. Whatever task we have to assign, that has to be distributed equally, or maybe some system kind of a failure. One system has to be a failure. That case, this system work has to be divided with the other nodes. Next, high performance. So doing up these systems or nodes in a cluster forms, what happens to here, which has to be produced with a high performance. So use cluster nodes to perform concurrent calculations. So main thing is it has to be concurrently calculated. So something, it has to be whatever given a data, that has to be whatever given a jobs, that has to be concurrently, it has to be a processing. Then allows application to work in parallel to enhance the performance of the applications. So always it has to be given as a high performance. So this is, we discuss about a type of a clusters. Now benefits. What are the benefits to given with a cluster system? Once to convert it from supercomputer to a computing cluster forms, what are the benefits? Now here compare with the mainframe systems, what it has to be what it is given as a benefit. So now first one we see here, reduced cost. So compared with the mainframe systems, now here desktops as implemented a recent year, here increasing the performance and power and performance. So reduced cost. The performance has given as a better to a mainframe systems. So we have to combine with a group of systems into a cluster form, that will be produced as a high performance. Now coming to a mainframe system, the mainframe system somewhat it has to be whatever your cluster form generated. The cluster systems has to be produced with a cost, comparing a cost that has to be somewhat less with the mainframe systems. Then processing power. So here parallel processing power of a high performance cluster can in many cases prove more cost effective than mainframe with a smaller power. So processing power. The power with the mainframe systems, the processing power has to be taken as a very less. With a simultaneously, it has to be executed more instructions. That's why processing power has to be very less with compared to a mainframe. At the same time, parallelly with once we have to enhance as a processing power, it has to be a ROI, greater ROI, right? Return on investment. That is also, that curve is also very high compared to a mainframe systems. And next one is the scalability. Mainframe system, that is a fixer. But coming to a cluster system, we can add a number of systems. For example, in clusters, we have a 5 systems. Then later we can add with a 100 of system. In addition 5, we can add with a 100. Up to 100 system we can add into a cluster. But mainframe system, that has to be a fix. That is a scalability. So in a cluster, we have to add a n number of systems at a time here now. But mainframe, it is a fixer. Improved network technology. This is the important. So now here typically via single virtual local area network, VLAN, through inside of this cluster system has to be through VLAN, virtual local area network. That is called virtual VLAN. Connected with a VLAN. Then this VLAN has to be interconnection. It is a somewhat delay in between cluster to cluster communication. So small delay in between. From one system has to be connected with other system. One node has to be connected with other. It has to be a small latency time has to be taken. So this is the improved network technology. Next, availability. Always, if it is availability in the sense, in a mainframe computer phase, entire system has to be failure. But in a cluster systems, one, it has to be a failure. It has to be transferred. Whatever the work we have assigned with that system, that will be given to a other systems. So that is a availability. Always the cluster system, always it should be a given high performance. Always it should be available. So this is the benefits about a clusters. Invention about a high performance company. What invention you are done? So observe here, need for even increasing performance. So first, even still we have given as a better result, but still we have to see a more increasing performance. That is the one criteria. Increasing performance. That is the important thing. Other one is a visionary concept of a parallel computer. So these two will focus on a invention. Now see here, what are the cases? Why we need even increasing performance? See, computational power is increasing, so our computation problems and needs, our computational problems and needs, we'll see case 1, case 2, case 3 like this. First one, complete time consuming operation in a less time. So case 1 we have to consider with a complete a time consuming operation in a less time. For example, if you want to design with a car, so whatever we design with a uh, car, that will be a simulation very in a simple manner, that has to be implemented here. Very time consuming operation is a less time, but actually in a blueprint that will be drawn in a other form, it may be take a long time. But coming to this high performance computations, then that will be whatever design we have fuel design of a car, that will be very simple. So that's why we tell to here now, complete a time consuming operation in a less time. So that is a we consider with a case 1. So automotive engineer, that has to be automotive engineer that is designed with a model car. So that will be a very less amount of time they will be designed with a new car. So that is a case 1. Now see second thing, what is that? Complete operation under a tight deadline. For example, weather forecasting. I want to know that some of the agencies, weather forecasting agencies, so that will be aim to finding tomorrow's weather by today. So that is the thing, predicting tomorrow's weather by today. So that is comes under complete an operation by tight deadline. So this is a case 2. We consider with a case 2. And case 3 is performing high number of operations per second. So this is the important thing, high number of operations per second. For example, if you take Amazon web server, per seconds, each second that will be approximately taking for 100 1000 instructions, 1000 transactions per seconds. So that is a 1000 transactions per 1000 transactions per second, so that customer don't experience bad delays. So that's why we need for increasing the performance of the systems. So 3 cases for evaluating time, less time we have to implement. What is the case 1 here now? So time consuming, complete time consuming operation in a less time. And second thing is a tight deadlines. And third one is a transactions, high number of operations per seconds. Perform high number of operations per second. So that is a 3 things that will be focused. Still we have to improve a high performance, increasing performance. So this is the why we need increasing performance now. So some of the examples we'll see here: climate modeling, and a drug discovery. So high performance computing, whatever drugs we have designed, that has to be used with help of high performance computing. Other thing is a data analysis. For analysis of a data, day to day, we have to number of transactions see in internet. So we have to analyzing data. This is very difficult task. So with the help of high performance computing, we can somewhat up to some certain range we can analyze the data. And protein folding and energy resources. So these are some of the applications we can use for a high performance computing. Why we are using high performance in computing systems? So in the initial definition I told that complex problems. So we can solve the conventional computation with a complex task. We can solve with a complex task. So that is a aim for a high performance computing systems. Now see here, what are the topics to included here? Artificial intelligence. The high performance computing we can solve with a AI, artificial intelligence. And the other thing is climate modeling, automatic engineering, and molecular dynamics. These are physical oceanography, quantum physics, and solid state physics, geophysics, cryptographic analysis. This is a very important thing in day-to-day life. We have to cryptography, conversion from one form to other form. The text has to be converted here. So for that, we have to use for high performance computing systems, and molecular biology, nuclear physics, plasma physics, quantum chemistry, structural dynamics. So all these are will be with the help of use of a high performance computing systems. Still, even it has to be expected for a more performance. So now coming to this HPC, high performance is currently applied to a business. So one is the data warehouses. Data warehouse is nothing but a large amount of data we can store at a place. So transaction processing, like day to day, Amazon, for example, if we take as a transaction processing, day to day per second, we can see that 1,000 hits for that website. So per second, 1,000, approximately 1,000 hits per. So it has to be a transaction processing. We want to processing of the transaction in Amazon sites or whatever business sites. We have to see that apply the high performance computing in those fields also, business sectors also. Here, observe the top 10 supercomputer and high performance computing. What are the top 10 here now? So this is one of the mission which I have contained in China. So now here National University of Defense Technology in China, which is one of the high performance in computing systems. That is a system. This is a system configuration that HPC, high performance in computing system configuration, and this is a core process. A number of cores. Cores means simultaneously executing the instructions. Core in the sense it has to be executing the number of instructions. So how many cores of systems is there? So approximately 31 lakhs 20,000. Approximately 31 lakhs 20,000 cores in that high performance in computing system. And similarly, United States is also contained one of the high performance in computing system that have with a core system like this. That is that number of cores, approximately 5 lakhs 60,640. And other thing is also have a United States. This is a configuration for that IBM system. This is a configuration for that high performance in computer systems, and this number of core systems. And Japan is also contained one of the fourth position, that is Raikkonen. And the other thing is United States, other also United States, sixth one also, seventh one Germany, and eighth one United States, Germany, China. So almost United States and China, Germany. This will maintain as a high performance in computing systems with a number of core systems. This is called in this column represent with a number of core systems. How many core systems are combined in that? Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.